Hi, everybody, and welcome to our first lecture. This is for week 1. The first thing we're going to do is talk about what is an integer. But I don't want to really start with what is an integer. I'm going to kind of build a little picture for you. Here's how it goes. In the very center, we have a circle, and inside this circle, we have what's called, I'm going to just have like a little legend down here. This is natural numbers. Because if you're ever asked for something to be a natural number, you have to know what that means. A natural number is a counting number. What I mean by that is what numbers do we count with? We count with 1, 2, 3, and so on. We wouldn't start with 0 because it would be weird to count like how many things you have starting with 0. Natural numbers are counting numbers. And then if we step out one step, we have what's called whole numbers. Whole numbers are really natural numbers because if you notice, the whole numbers are surrounding the natural numbers. That means the natural numbers exist inside of it. Whole numbers. And they're natural numbers and 0. They just start at 0 and then everything else is a natural number. Now, integers are outside of that. So if I draw another circle out here, we use the symbol that looks like this. It looks like a Z. Integers are, notice again, they're outside of what we have. So everything that we've talked about is included in integers. We add all the negative numbers. We start at negative infinity, -2, -1, 0, 1, 2, and so on. They cannot have fractions. They cannot have decimals. Everything we've talked about so far are whole numbers. Now we make our big box outside. And this box is divided into 2 pieces. What does the box represent? The box represents real numbers. And real numbers are any number that you put on a number line. Real numbers are all numbers that you can put on a number line. These boxes now, what do they mean? And they're divided into 2 pieces. This piece is called rational numbers. And I bet you can guess the other is called irrational numbers. And rational numbers actually have this symbol you may see. It's like a Q. Rational numbers are any number that can be represented as a fraction. We call it P over Q, where P and Q are integers with one exception, and I'll put it over here on the side. The denominator Q cannot be equal to 0. We can never divide by 0. Also, we include decimals, because decimals really can be expressed as fractions as well. So we include decimals that terminate. What does that mean? 0.5 is a terminating decimal. it ends, or repeating decimals. So if you were to take 1 divided by 3, which is 1/3, you would see that it's 0.33333, and it never ends. It just goes out to infinity as threes. Those do count as rational numbers because they also can be represented as a fraction, 1/3. Things that don't repeat and don't terminate are not rational, and irrational numbers, pi, the square root of 2, square root of 3, the square root of any number that is not a perfect square is probably irrational. For example, the square root of 4 is 2. That would be in natural numbers, whole numbers, integers, and rational numbers. It would not be irrational because the answer is a number.
Like 7?
You mean square root of 7?
Yeah.
Square root of 7, exactly.
Okay.
It doesn't, square root of 8, square root of 10, square root of 9 would be natural, whole, integer, and rational because it's 3.
So if it's all of them, is there a certain name for them or no? It's just all categories.
If they're all of them, there's never going to be all of them because they can be under rational or they can be under irrational. They can't be both.
Okay, sounds good.
Okay, integer. How can you tell me if 19 over 13 is an integer?
It's not.
Good.
Because it's a fraction.
Not because it's a fraction. First of all, do you understand that fractions are really just division?
Yeah.
Okay, so if you divide 19 by 13, you're going to end up with not a whole number.
Yeah, you're going to end up like a decimal.
Yes, you're going to have a decimal. That's why it's not an integer. Negative 91.6.
That'd be an integer or integers.
This would be an integer?
Yeah, because it's negative and it's... Oh, wait, no, there's a decimal in it. So no.
Right, exactly. Perfect. How about negative 5 over 5?
I'm going to say no. It is?
It is, because if you put that into a calculator, it's really
you
negative.
get 1. Oh, okay. Yeah. So even if I can divide it, it would be an integer?
Yes. As long as in its simplest form, it's an integer. This will not have a decimal.
Okay.
This should be an integer. How about negative 650.51?
No.
Good. And how about 88?
Yes.
Perfect. This one, which is identifying rational and irrational numbers. Let's see if you understood what I said. It's okay if you didn't.
Okay.
Negative 21.31. And that thing on the top, that line means it's a repeating decimal.
So it'd be rational. Perfect.
It would be rational. Negative the square root of 9.
Well, I know you can make that like divided by, make it a 3.
Mm-hmm. So and then you have negative outside. So you'd have, that would actually be the same as negative 3.
Yeah. So it would be irrational, right?
Absolutely. You're doing great. How about negative 14 pi?
Irrational?
It's irrational because once you put pi into it, pi never ends. And we don't have a number and we don't have a fraction. We don't have any fraction to represent it. So anything times that is always going to be irrational. Even the square root of 2, 5 times the square root of 2 is still irrational because the square root of 2 is irrational. As a matter of fact, it looks like I just answered the next question.
Yeah. So irrational for that one.
Okay, so this is irrational. Does it make sense?
Yes.
Okay, and then negative 3/2.
I think rational because it'd be like 1.5, right? If you divide it, or
yeah, and really it actually fits the definition of a rational number. So any number that can be represented as a fraction, well, that is a fraction. P over Q, P is 3, Q is 2. P and Q are integers, or 3 and 2 integers?
Yes.
Okay. Also, we include decimals that terminate or repeating decimals. So,
okay.
Does that make sense? Does that definition now make a little more sense?
Yeah, that helps. Thank you.
Okay, negative 3/2.
Rational. I meant negative 2 with the square root. So I know like negative 2 is technically like a positive, and can it keep going on? But it's irrational because of the square root. Like
Exactly. Like if you put the square root of 3 into your calculator, it would be a number that would just keep going. It would never repeat. It would just go on forever. If you take that number, whatever that is, and multiply it by anything or divide it by anything, it's still going to do the same thing.
Because with 9, you can go to 3, like with a square.
Right. The square root of 9 is 3. So 3, and then it's negative is -3. That's definitely an integer. That's not what the question is asking. It's asking, is it rational or irrational? But if we were to put it into its smaller category, we would say that's an integer. We could not go any lower because it's negative, and whole numbers and natural numbers, notice, don't have any negative numbers. So if we were to put it in its smallest place, it would have to be an integer.